अस्सलाम वालेकुम। हमारे पास अब डेरिवेटिव्स के डेफिनेशंस और एग्जांपल्स हैं। डेरिवेटिव्स को मजीद आगे बढ़ाते हैं उसके रूल्स सीखने के लिए और लॉ सीखने के लिए, ताकि हमें और आसानी हो डेरिवेटिव मालूम करने के लिए। So we have the rules for differentiation, including the constant rule with the example, the power rule, constant multiple rule, sum rule, and difference rule, and their examples, the horizontal tangents. First of all, we have a constant rule. It says that if the derivative of a constant is its slope, then for a constant function, the derivative must be 0. So here is the definition. D to the dx of any constant is always 0. For example, we have a constant, we have a function y equals to 3, and the derivative of this 3, because it is a constant, as we apply this rule, constant rule, d to the dx of any constant, d to the dx of constant is always 0. So y prime of 3, by the definition, we have 3. So the derivative of a constant is always 0. So f prime of x, here is a proof of this constant rule, that whether it is true or not. Mathematics किसी हिस्ट्री के सब्जेक्ट की तरह है कि इसमें कोई भी जो नोटेशन फार्मूला एम्बिगुअस नहीं है, सब प्रूव्ड हैं इसमें। तो इसको प्रूव करके देखते हैं कि आया कि ये कांस्टेंट जो हमारे पास है इसका डेरिवेटिव ऑलवेज 0 होगा कि नहीं होगा। तो हम इस बेसिक फंक्शन को डेफिनेशन ऑफ द डेरिवेटिव्स जो हमने पढ़ी थी उसमें प्लग करके देखेंगे कि हमें आंसर क्या मिलता है। तो वी हैव अ डेफिनेशन, f prime of x equals to limit where h tends to 0, f of x plus h minus f of x all over h. Limit, we have f of x plus h, a constant, so we have a constant here, minus sign by the formula. So we have a minus sign here. F of x is a constant, so we have a constant. Minus c and plus c will be cancelled out. We will end up with h. H is 0 here. So the limit where h tends to 0, we have 0 equals to 0. Hence prove that the derivative of any constant is always 0. As we can see that we have a function, a constant c here. So add this line, add this the c number here. C number can be 1, 2, 3, 4, 5, anything. So at this particular line, the slope of this line everywhere we will get 0. Okay, so this is the proof for the constant rule. Let's move ahead. We have a power rule. So for this rule, first of all, let's consider the family of power functions. What we have, f of x equals to x power n. This power n could be or can be 0, 1, 2, 3, 4, 5, and so on. So it is better to explore that what is the derivative of such functions having the powers. So we consider here, if n equals to 0, what will happen? Wherever we have a function that f of x equals to x power 0, we cannot abbreviate or pronounce it as a x naught, but x power 0 equals to always 1. Whenever, provided, whenever x is not equal to 0, x is not 0 itself. So we have a proof here that, like the constants, f prime of x equals to limit where h tends to 0, f of x plus h minus f of x all over h. So we have x power 0 equals to 1, 1 minus 1. If we plug this value in this definition, we will end up with 0. Hence prove once again that the derivative of any constant is 0. You can see at this line, everywhere the slope is 0. At this line 1, everywhere the slope is 0. If we add 2, 3, and 4, the slope of that particular constant, specific constant, is always 0. So what about if n equals to 1? Usually what we do, we have a function f of x equals to x power n. Usually we do not write this power n, but we assume that here is a power, there is a power 1. X power 1 equals to 1 always. So if we take the derivative of this function f of x, x power 1, we have d to the dx of x equals to always 1. We will end up that the function always have the slope of 1, and this gives us a function, what we say, 45-degree line. Okay, so some easy examples of constant rule, then we again move to the power rule. So first of all, the examples, f of x equals to 4. By definition, putting the 4 and taking the derivative of this constant 4, we have 0. F of z equals to 100. The derivative of f prime of 100, f of z will be 0 because it's a constant. What will be f of t if it is equaling to minus 22? It is f prime of minus 22, or f prime of t will be 0. So n is so simple. So we have a power rule again, as I promised you. If n equals to 2, 3, 4, and 5, what will happen if the power is getting higher? So d to the dx, where we have x to the power n. This n could be 2, 3, 4, 5, 6, 7, 8, and so on. So we have a rule here that for any power, we have a power n minus b power n. So by factoring it out, we will get that the a minus b times a power n minus 1, and b is 0 here. So we left b. So b is 0 here, and b has a power 0, and from this a will be uh, lessened out with respect to b. How? Because plus a power n minus 2. Here you can notice that n minus 1, n minus 2. Okay, b plus dot 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 plus a b power a times b power n minus 2 plus b power n minus 1. So यहाँ पे हम नोटिस करेंगे कि a पावर में b से बड़ा है, b पावर 0 है। यहाँ पे आहिस्ता आहिस्ता b का पावर बढ़ता जाएगा और a का पावर कम होता जाएगा। ठीक है, तो यहाँ पे हम देखेंगे कि a का पावर 1 है और b का पावर बढ़ गया। यहाँ पे a का पावर 0 है और b का पावर n-1 है। फर्दर इसको प्रूव करने के लिए हम देखेंगे कि हमारे पास एक थ्योरम है that says that if n equals to 1, 2, 3, 4, and 5, the same rule, then we have d to the dx x power n equals to, हम इस n को आगे की तरफ लिखेंगे, we will pull out this n to the front, n को आगे की तरफ देखेंगे और इस n में से -1 कर देंगे। ये -1 ऐसे ही नहीं आया, हम इसको प्रूव करेंगे कि -1 कैसे आता है यहाँ पे, ठीक है। सो बाय द डेफिनेशन वी हैव n times x power n minus 1. So we have a definition here. d to the dx x power n equals to limit s tends to 0 x plus h power n, because we have here f of x and we have x power h power n minus the original function x to the n. So हम इसको सेम लाइक a पावर n माइनस b पावर n की तरह फैक्टराइज करेंगे all over the h. So we have that by the definition d to the dx x power n equals to n times x power n minus 1. f of x equals to x power 4. इस पावर 4 को हम आगे की तरफ लिखेंगे. It will be f prime of x equals to 4x, and it will be 4 minus 1 cubed. 4 minus 1, it will be 4x cubed. Okay, so y equals to x power 8, and y prime will be 8x power 7. So simple, so handy, it's a power rule. So let's define and let's solve it. As we've seen there, that the limit, we are starting from the previous, that as limit h approaches to 0, we will pull out that 1 over h, where x plus h minus 1, if we factorize, and times x plus h power n minus 1 plus x plus h power n minus 2 times h, plus dot dot dot, we have x plus h times x power n minus 2 plus x power n minus 1 here. So we will end up, if we solve it, we will end up with, ओके तो हम इसको सॉल्व कैसे करेंगे, जहां पर भी h है उसकी वैल्यू हम 0 पुट कर देंगे, तो हमें मिलेगा x पावर n माइनस 1 प्लस x पावर n माइनस 2x प्लस डॉट 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 प्लस x टाइम्स x पावर n माइनस 2 प्लस x पावर n माइनस 1. तो इस टर्म से लेकर, शुरुआत से लेकर यहां तक हम देखेंगे तो हमारे पास n टर्म्स है, n टर्म्स हैं और एक और टर्म है हमारे पास n माइनस 1. तो ये हो जाएगा n टाइम्स x पावर n माइनस 1. तो यहाँ पे प्रूव हो गया कि हमारे पास ये फार्मूला कैसे आ गया. So if we find the derivative with respect to quotients, we have always that the d to the dx of x square, we have a square function here. So by putting it in the definition, we will have the x, and x will be replaced with x plus h square by the definition, original definition, minus x square, the original formula, all over the h. So it will be, if we factorize it, x square plus 2xh plus h square minus this x square all over the h. So we will cancel out the plus x square and minus x square, and this h by this h will be cancelled. Okay, what we'll end up with 2x. Okay, so what about the d to the dx x cubed equals to limit where h tends to 0 x plus h cubed minus x cubed all over h. So by putting it in the original definition and simplifying it, we will have that the limit where h tends to 0, by factoring it, x cubed plus 3x square h plus 3x h square plus h cubed minus, by the formula, x cubed all over h. And we see that this minus x cubed and plus x cubed will be cancelled out, and then h's will be divided as cancelled out. We have h square here because this is h cube and we have a single h here. So we will end up with 3x square. Okay. Here, if we put the value of h as a 0, we will have this term as a 0. So we will end up with 3x square. And then what about the d to the dx of x power 4? Well, it's so simple like these terms. Are these functions? We have limit where h tends to 0, x, we will factorize it, that x power 4 plus 4x cube h plus 6x square h square plus 4x h cube plus h power 4 minus 4 all over h. So x power 4 of plus and x power 4 of minus will be cancelled, and then h's will be cancelled. We will leave it here h square. So if we end up here h square, we replace it by 0, then 4x times 0 will be 0 elsewhere. So we will left with 4x cubed here. Okay. So we observe a pattern. You can observe here clearly that 2x, 3x square, 4x cubed, and likewise 5x power 4, 6x power 5, 7x power 6, and 8x power 7, and so on. So the power rule says that d to the dx of x to the n equals to n x power n minus 1. So we have seen the proof, and once again that d to the dx, where we have x power n equals to, for your reminder, that limit where h tends to 0, x plus h power n minus x power n all over h. Likewise, we have that. We have seen this before, that where the x power n plus nx power n minus 1h plus dot 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 h power n minus x power n. So this x power n of plus x power n of minus will be cancelled out, h's will be cancelled out, and we'll leave it with end up with n x power n minus 1. And it's proved once again. So let's dive into the examples. That we have a function of the power rule, that f of x equals to 5x plus 4. We know that this a 5 times x, or 5 of 5x, this x has the power 1 plus 4 is a constant. Constant will be 0. We will end up with 5. Here we have 1, that 1x. It will become 1. 5 into 1 we have the f prime of x equals to 5. What about the f of x equals to pi cubed? We know that the pi is a constant. So any constant, whether it has a power, the derivative of that constant will be 0. F prime of x equals to 0. What about f of z equals to z square plus 3z plus 6. We see that this is a z square, so we pull out 2 here, and 2z minus 2 power 2 minus 1 will become 1. We have 2z here, and plus 3z. Z is a 1 power, so it will be 3 into 1, 3 plus 6. 6 is a constant, so it will be 0. Equals to f prime of z equals to 2z plus 3. This is the derivative of this function. F of x equals to, we have another function, f of x equals to x plus 4 times 2x minus 1. ओके, तो जब हमारे पास ऐसी ऐसी किस्म की मल्टीप्लिकेशन आ जाती हैं तो थोड़ा सा इसको देखने की ज़रूरत है कि वेदर इसको हम ऐसे ही सॉल्व करें या कोई और टेक्निक इस्तेमाल करें, जैसे कि इसको फर्दर सिंप्लीफाई करें और फिर उसका डेरिवेटिव निकालें। तो यहाँ पे ज़रूरत यह है कि इसको हम फर्दर सिंप्लीफाई करें। x to the x times 2x, it will be 2x square plus 7x minus 4. अब हम इसका डेरिवेटिव निकाल सकते हैं। तो डेरिवेटिव ऑफ 2x square plus 7x minus 4 will be, this 2 will be pulled out here. So 2 times 2 will be 4. Okay. And 2 minus 1 will be 1. It will be 4x plus 7x. X is a 1. 7 into 1 will be 7 minus 4. Minus 4. Here we have a constant 4. So the derivative of a constant is 0. Further simplify that. If f prime of x equals to 2 to 2x, pull out 2 here, plus 7, 4x plus 7. So what about another problem? F of x equals to under root 5x. We know that this under root 5x is the radical 5 times radical x. If you write in this way, that radical 5 times x to the power, if we remove the radical, we will end up with power 1/2. जैसा कि हमने रेडिकल्स के पावर के बारे में थोड़ा सा पढ़ा था, उसको थोड़ा सा रिकॉल कर लीजिएगा. Equals to, if we further solve it, now we take the derivative of this function, radical 5 times x power 1/2. So f prime of x equals to under root 5. We apply the power rule here, that this 1/2 will be pulled to the front of this x. It will be 1/2 times x power, these powers will be negative, minus 1/2. So if you write in this way, equals to radical 5, this negative sign shows that this is the denominator, this goes to the denominator, 2x power 1/2. We will end up with that, if we write it as in this way, अगर इसको हम इस फॉर्म में लिखें तो भी सही है, डेरिवेटिव इसका यही रहेगा. उसको फर्दर सॉल्व करेंगे तो इट्स x power 1/2, it will be 2 to the radical x. So we will end up with under root 5 over 2 under root x. और एग्जाम्पल है हमारे पास एक कि f of x equals to 3x square plus x minus 4 all over x cubed. अच्छा जी, यहाँ पे हम इसको देखेंगे क्या इसको फर्दर सॉल्व करें या इसी का डेरिवेटिव निकालें. तो ज़रूरत है कि इसको फर्दर सॉल्व करें. ठीक है, 3x स्क्वायर प्लस x माइनस 4 ऑल ओवर दी x क्यूब. तो हमारे पास है कि 3x स्क्वायर, इसको ऐसे लिखें तो गलत नहीं होगा, ओवर x क्यूब प्लस x ओवर x cubed minus 4 upon x cubed. So we will have that this cube will be divided by this or pulled to the numerator. We see that in division the powers will be subtracted. 3x power minus 1 plus x minus x power minus 2 minus 4x power cubed. So अब हमारे पास ये फंक्शन है, इसका डेरिवेटिव निकालेंगे. f prime of x equals to minus 3x minus 2. Why minus 2 here? Because by the rule we pull out minus 1 to the front, it will be multiplied by this 3. This 3 will become 3 times minus 1 minus 3. So by the rule, in the powers we subtract minus 1. This is a power minus 1, and by the rule, we subtract minus 1 here. Minus 1 and minus 1 will become minus 2. So, in numbers, the power will get higher. Okay, minus 3 x power minus 2 minus 2 x power minus 3 plus 12x minus 4, because all the powers are in minus, and if we solve it by the rule that minus 1, here is a power minus 1, and we by the rule minus 1 here, so we will end up with minus 2 and minus 1 minus 3 and minus 1 will be minus 4, so it will be equal to minus 3 over x square minus 2 over x cubed plus 12 over x power 4. So now we have a constant multiple rule with its proof. This is a constant multiple rule, d to the dx over a constant multiplied with u. U means that there is a function of any function, c times f of x, c times u, both are same, equals to c du dx. And we have a proof here. So by this proof, we see that we have a function, let g of x is a function equals to c of f of x, any constant and a function. Then g prime of x will be the limit h tends to 0, g x plus h, g times x plus h minus g of x, its original function, all over h, equals to limit h tends to 0, c f of x plus h minus c f of x all over h. Now further solve it. So we pull out the constant in front and solve these, that the limit h tends to 0, the constant multiplied by f of x plus 1, f of x plus h minus f of x all over h, and this constant by taking the limit of this function. So we have f of x plus h, h will be 0, f of x minus f of x. Cancel out and we will end up with 1. So we see that we have constant multiplied by f prime of x here. So this is by the law 3 of the limits, if you recall. So when we use the difference quotient, we observed that since the limit had no effect on a constant coefficient, that a constant could be factored to the outside. So for example, we have a constant here d to the dx, and a constant multiplied by x power n equals to c, a constant, n to the front, nx by the power rule. This will be by the power rule, nx power, we cannot say n times x power n minus 1 here. So we have example, a small example here, that d to the dx 7x power 5. The 7 will be will not be affected by this x. So 7 times 5, and 5 minus 1 will be 4. So 7 times 5 times x, 7 times 5x power 4, it will become 35. 7 times 5, 35 x power 4. So further examples of constant multiple rule, we have the first problem, f of x equals to 5x plus 12x square. So by taking the derivatives of this constant multiple rule, constant multiples, we have that f prime of x equals to x times 5. It will be 5 because it's not a constant, but it's a constant multiple, plus 12x square. 2 will be pulled out to the front and multiplied with 12 we will end up with 24x. Okay. Another example, f of x equals to 3x cubed. So 3 will be pulled out to the front and multiplied with the 3, and 3 minus 1 will become 2. So f prime of x equals to 9x square. Now likewise, f of z equals to 7z square plus 16 equals to f prime of z. It will be only, because 16 is a constant, it will be 0. It will be 0. 7z square will become that 2 to the front multiplied with constant 7 by 2. 2 times 7, 14, and 2 minus 1 powers. 2 minus 1 will be 1z. 14z here. F of x equals to 17x. We will end up with 17 only. So, sum and difference rules. Okay, the theorem says that if f is a function and g is another function, if f and g are both differentiable, have a derivative, have a limit there at that specific point. If f and g are both differentiable, then derivative to the dx of f of x plus g of x equals to d to the dx f of x plus d to the dx g of x. Okay, so using the prime notation, so we can write the sum rule that f of f plus g prime times f prime plus g prime. Likewise, as a sum rule, f minus g prime whole prime equals to f prime minus g prime. So for the proof for this rule is that let f of x equals to f of x plus g of x, then f of x, f prime of x limit equals to limit h tends to 0, f of x plus h minus f of x all over h. So by solving it, we will have that the limit where h tends to 0, f of x plus h plus g of x plus h minus f of x plus g of x all over h. If we solve this by the original definition, equals to limit h tends to 0, f of x plus h minus f of x all over h plus sign here, g of x plus h minus g of x all over h. So if we solve this, we'll end up with that limit h tends to 0, f of x plus h minus f of x all over h plus the limit g of x plus h minus g of x all over h. So further cancelling the like terms, and we will end up with equals to f prime of x plus g prime of x here. That's proved. So if we see that we have two terms, f of x and g of x, and we say that the f of x is u and g of x is v. So sum will be du to the dx plus dv to the dx. This makes sense because the limit is tends to 0, f of x plus h plus g of x plus h minus f of x plus g of x all over h. The limit will be limit h tends to 0, f of x plus h minus f of x all over h plus the limit h tends to 0, g of x plus h minus g of x all over h. So it will become d to the dx, same like for the u minus v, means f of x minus g of x. It will become du, derivative of f of x with respect to x, du dx, minus dv, derivative of g of x with respect to x, dv over dx. So what about this? We have y equals to x power 4 plus 12x. So by the formula, we have that we take derivative of this and we sum it with the derivative of this term. So we have that y prime 4x cubed plus 12. Each term will be treated separately. So we see that another example, x power 4 minus 2x square plus 2. 4x cubed minus 4x. Because this 2 is a constant, it will be 0. So for illustrating these examples, we have constant multiple rule, the sum rule, difference rule can be combined with the power rule to differentiate any polynomial, your favorite one. We have a polynomial that d to the dx of this function 8 power x power 8 plus 12x power 5 minus 4x power 4 plus 10x cubed minus 6x plus 5. Sorry, I omitted the second bracket here. The d to the dx of this term will be x power 8 plus 12, the derivative of x power 5 minus 4, the constant, will be untouched, times d to the dx x power 4 plus 10 is a constant, so it will be untouched. The derivative of this x cube minus 6 will be untouched. D to the dx of this x plus this constant d to the dx 5. So by solving this, we have the derivative of x power 8, 8x power 7, plus sign remains same, 12, and 5x power 4 minus 4 times 4x cubed plus 10 times 3x square minus 6 times 1, because it's a single x. So this is a 1 power 6 plus this constant will become 0. So by further solving, 8x power 7 plus 60x power 4 minus 16x cubed plus 30x square minus 6. So likewise, if you remember that, if you remember all these rules, that यहाँ पे देखें कि ये हमारे पास पावर रूल है, ये सम रूल हो गया, फिर constant multiple rule, and then the constant multiple rule, and then we have a sum rule here, constant rule. So what about the horizontal tangents? So by using these laws, we can find now the horizontal tangents. We know that the horizontal tangents, we have derivatives at which the value is 0. Tangent is 0 always. Okay. Slope इसका 0 होगा. Okay, so find the horizontal tangent of this value, y equals to x power 4 minus 2x square plus 2. This will be dy to the dx equals to 4x cube minus 4x. Horizontal tangent occurs when the slope is 0. 4x cube minus 4x equals to 0. So जब हम इसका डेरिवेटिव निकालेंगे तो इसका जो भी डेरिवेटिव आएगा वो ही हमारे पास टेंजेंट स्लोप मालूम करने के लिए फार्मूला होगा. ये आप नोट डाउन कर दें कि जो भी जिस फंक्शन का डेरिवेटिव हम निकालेंगे, पर्टिकुलर फंक्शन का, इस फंक्शन का जैसे कि डेरिवेटिव ये है, तो ये डेरिवेटिव हमारे पास फार्मूला है स्लोप ऑफ हॉरिजॉन्टल टेंजेंट्स मालूम करने का. ओके, सो वी हैव 4x cube minus 4x equals to 0. Further, we solve it that x cube minus x, because 4 will be cancelled. So if we get common x here, we will end up with x times x square minus 1 equals to 0. If we further factorize it, then x times x plus 1 times x minus 1 all equaling 0. So we will end up with x equals to 0, minus 1 and 1 here. तो हमारे पास ये हॉरिजॉन्टल टेंजेंट्स मालूम करने के लिए ये 3 पॉइंट्स हैं, 0 minus 1 and 0 minus 1, sorry, 0 minus 1 and 1. Substituting the value of x into the original equation, we get that y equals to 2, y equals to 1, and y equals to 1 here. There is a minus 1, we omitted here. So the function is even, and we only get 2 horizontal tangents here. So find the horizontal tangent of the original function y equals to x power 4 minus 2x square plus 2 We have a formula, and horizontal tangent occurs when we have 0. Okay, the plugging the value, we will get all these values here. And if we plot this, what we have? We have a function y equals to x power 4 minus 2x square plus 2. And we have a point where the tangent is a horizontal. There is a y equals to 2 and y equals to 1. And also, we plot this that these are the points where d to the dx equals to 4x cubed minus 4x. We have minus 1, 0, and 1 here. These are the 3 points where the tangents are 0. First derivative slope is 0 at x equals to 0, minus 1, and 1. Okay, the second example for the horizontal tangents. Find all the values of x at which the tangent line to the curve is horizontal. We have a function y equals to x squared plus 1 over x minus 1. So d to the dx, we further factorize it, x minus 1 2x minus x squared plus 1 times 1. So 2x squared, simplifying it, solving it, 2x squared minus 2x. Why 2x squared minus 2x? Because we multiply this with 2x, 2x squared minus this sign will be here. So 2x times 1 will be 2x minus sign, this minus sign by the formula x square minus 1 here. So minus into plus will be minus all over x minus 1 whole square. If you further solve it, that 2x square minus 2x minus x square minus 1, x minus 1 whole square. We will end up with that the x square and 2x square. We subtract minus x square from 2x square. We will end up with x square x square minus 2x minus 1 all over the x minus 1 whole square. Now we have the formula. This is the formula. So the horizontal tangent has a slope 0, we remember. So for this, we like to find the x such that d to the dx or horizontal tangent or derivative will be 0. So we have a formula that x square minus 2x minus 1 equals to 0. अगर हम इसको देखें कि ये जो हमारे पास फार्मूला है, इसको फर्दर हम सॉल्व करें तो क्या ये मजीद सॉल्व होगा? नहीं. तो इस इक्वेशन को देखने के बाद हमें ये जहन में आता है कि ये एक क्वाड्रेटिक इक्वेशन है, तो हम इसको क्वाड्रेटिक फार्मूला की मदद से हल करेंगे. क्वाड्रेटिक फार्मूला मैंने आपकी फैसिलिटी के लिए यहाँ पे लिख दिया है. इट इज अ x equals to minus b plus minus radical b square minus 4ac all over 2a, where ax square plus bx plus c is 0 and abc are constant wherever or whenever provided that a is not equal to 0. X is the unknown here. So by putting this value or plugging this value that x equals to a, b, and c, it will become that 2 minus plus under root 2 square minus 4 times 1 because the c is 1, okay, and a is 1, so minus 1 all over the 2 times 1. Further solve it that 2 minus plus 4 times, this will be 4 times 2 because 2 times 4, we write here that 4 by 2 all over the 2 equals to 2 minus plus 2 under root 2 over 2. By further solving that, we have equals to 1 plus under root 2 and 1 minus under root 2. These are the two values where we have the horizontal tangents. And that's all.